number in front of x, whatever comes up, if it's 2.3 or 1.8 or negative 1.2. This number, do you remember what this number is?
Constant.
It's the slope intercept. I don't need you to be so concerned with that. We'll talk about that. We're not going to be so concerned with the slope, oh excuse me, that's the slope, it's the y-intercept. I apologize. I put down the slope intercept. It's called the y-intercept. It's the number where the line would actually cross the y-axis. We are not going to be so concerned with that in a lot of these problems. You know why? Do you really care what's going on when someone had a club speed of 0? Think about it, everyone. Would we be so concerned with someone who had a club speed of 0? I guess that means they missed the what? They missed the ball and stuff, right? The ball's not going to go anywhere, yeah. So that's what we're talking about. So don't get so worried. But this is the slope. Okay? Now, we're going to use the technology to get this. But before we do, how would you produce this by hand? So I'm going to go to the formula sheet. I'm going to write the formulas on this that's coming from here, how we can determine this. Because it comes from all this right here. And it comes from that R value we found, okay? So here's the formulas for it. This is on your sheet. And notice, everyone, when we write this equation, and see, I wanted to put this with other variables. We've got B naught equals y bar minus b sub 1 x bar. All right? So if you want to copy those, great. Those are available where? On the formula sheet. But if we wanted to do this by hand, right? If you and I want to do this math problem and answer letter C by hand, then it looks like we've got some tedious calculations. Do you agree? I mean, let's look through here. First of all, I need to put the R value here that we had before, the point what? 99. Then I have to get the standard deviation of all the what?
Y.
Y values. I know, it's like, whoa, okay, I can do it, but I can get that. And then I have the standard deviation of the what?
X value.
X values, okay, I can do that. And I get this, and I get this number. And I can put that there, and that's the slope, right? That'd be my slope. So you're like, oh, that'd be my slope. This would be my slope. Now, this B naught symbol, that's that y-intercept I was talking about. I'd have to take the y bar, the average of all the y values, subtract the b sub 1 value I just got, the slope, multiplied to the x bar. And we could go through that, couldn't we? You all agree? Yeah. We could spend the next 10 minutes doing all this math to come up with it. But again, welcome to statistics, everyone. This really isn't a math course. I know we do a lot of mathematics. More important to us is what? The interpretation of this, right? We understand we can do all that, and we can spend the time doing it. More important to us is coming up with this, representing it, and knowing what it means and interpreting the slope, all right? That's what's important to us. So is everyone okay if we use the technology to do this? Cool. Because I know you could do all this. You found that when you showed me last night, you could do standard deviation of a set of variables. And you could find that R value as well. Can I erase all this down here? All right. So we're going to do this with that. All right. But our answer should be like a what? You know, when I use the letter you're familiar with. Something like this? Do you all agree? But when you write this, and I'll put it with yellow chalk, I want you to all put a hat on the Y. And you can call that Y hat. And the reason is, it's Y predicted. It's not really in the data, is it? It's going to be a model. So we're going to make a little line in this thing, but we're going to call it Y hat. It's got a funny hat on it. Sound good? All right, so I'll erase this. I'm going to get a little line here. You and I are going to come up with this. Again, can you go 3 values after the decimal place on every number we get? At least. If you want to go further, you can, but go at least what? 3 values after the decimal place like I did up there. All right, so how do we do this? Good news, everyone. We just got to look back at that screen we had. So I'm going to hit the lights. It was up there. I don't know if anybody caught it. Remember all that stuff that was above the R? It's in the same button. So I just go back and do it. You might see it on your screen right now. I'm going to go back. Oh, there it is, but I want to walk you through it in case someone blanked out the screen. Do you see it? It's all in there. They like to use A. I'll hit clear, though. I'm going to go through all this again since someone forgot how to do this. I go to Stat. I go to Edit. I go to Calc, excuse me. I go down to, we're in Chapter 4, so number 4 for bivariate data. Everything's in L1, L2. I just hit Enter. All right, so let's write this out. Would you put a hat on the Y, though? All right, I'll hit the light so you all can see this. y with the hat on it, right? See, when it's an equation has to have an equal sign. Y hat equals 3 point, go up 3 numbers.
166.
166, what letter goes next?
X.
X. Plus, now you gotta give me the big.
Negative 50.
Ooh, it's negative. 55.79
79.
and a 9. Go
And a
one more number,
6.
everyone. 7.
7, okay.
That's it. Awesome. Yeah, we could write this out further if you want. If you want to go more decimal, you can. And that's called the least squares regression line.
So instead of positive, you just put the negative with that little parentheses at the end?
You can do that. You could leave it like this, Randy. I was wondering if you had another suggestion. What do a lot of students like to do? I'm going to go to Holland. How do you write this?
Just
Minus.
Minus. Who else does that? Right? If you like, I prefer it too. I'm going to see, the majority class was like, yeah. A plus and negative in math, we can just write as a what? It looks better. So I think, Rainey, your idea was great. Please be able to do that. But I like that even better. We see plus now, we'll just put a subtraction sign. You know, the calculator, right? Awesome. So everyone, what's this line doing? This line, it's called the least squares regression line, is a model. It models the data. And we can use it to maybe perhaps make other predictions inside the scope of data. I'm looking in here, everyone. I see 100 miles per hour, 102, 103. Everyone, I don't see a golfer hit 104 miles per hour in there, do you?
No.
I don't see one with a 104. So in that case, I can make a prediction of perhaps what a 104 mile per hour club speed would get in terms of yards.
Oh, so
Right?
you just put 104 in place.
We just put a 104 in there. It'd be an estimate, but that's what we do in stats, right? And you can do this with a range of things. You look in the textbook, everyone, there's one problem where they took the circumference of child's heads and the height of the child. And sure enough, they saw a strong positive linear relation. Cool? Cool? All right. There's a bunch of others too. You know, weight of car, miles per gallon. You all understand this. The heavier the car, what happens to the miles per gallon? Kind of goes down. But these light cars, ooh, wow, you can get like 45 miles per gallon, but you might get an accident or something, right? Ooh, there was a question over here.
So I just want to clarify, so that equation is showing that, was the linear relation, correct?
That's right.
Okay.
That's it. This gave us the strength of the linear relationship. Now this is going to be a line, we're going to draw it, that's going to go through these dots. And right now you might go, well, I'm just going to draw a line like that. But I say we use the calculator. So let's go to the calculator. Let's see how this line looks. It should cut right through those dots, right? So, where do I need you to go? I need you to go to stat plot. Top left corner, only hit the light. I'm going to hit enter. Now, which one of those looks like a scatter plot?
The first one.
All right, so would you go to the first one and hit enter? Remember when you hit enter? Make it lock. Now watch what happens when I hit enter. Watch these change. The calculator, it's a smart calculator, it should know to read L1, L2. So I'm going to hit enter. Ooh, thank you. Now mine didn't do it. Did yours do L1, L2? Mine, I did this on purpose in class. I'm going, wait, I want L1. So all I have to do is go down here and change this to L1 off my front screen. But yours, I'm sure, automatically did that. I made it do that because I like playing around with the calculator. I'm like, oh, I got to fix that. Now, do you remember the zoom what for stats?
9.
Zoom stat is zoom 9. That's going to give us a nice image of this. All right? So we're going to do that first, and you're not going to see the line. And so I just want to give you a heads up. We're going to do this. All we're going to see is the scatter plot. Zoom 9. Ah, cool. That's what we got before. How do you find these numbers, though?
Trace.
All right, Owen, I want you to hit trace. It's right next to zoom. And you can move around. Does it work?
Yeah, I can go for one screen.
Oh, okay. I'll come over there if you need some help. And I'm getting all these. Want to see all the numbers? But you and I also want to see the what? The lines. So this is simply what we have to do. We haven't gone here yet. But you've been in algebra courses before. I'm just going to hit y equals in the top left. Not the stat plot. I'm just going to hit y equals. And I'm going to manually type in 3.166. Does everyone know where x is? X is right under mode. I'm just gonna go to y equal, just type this in. And then there's a minus, so let me see what the minus button is on the right side, on the right column. 55.797. And then I'm gonna just hit graph. I'm just gonna hit graph. Ooh, there it is. So I'm gonna do it with my yellow chalk right now. I'm gonna go like this. It came off here. It looks like right near that dot. And it cut through. Right there. This is called the Least-Squares Regression line. I think I'll hit the light. And I'm gonna label this. This is called y-hat, right? So Liz, this is the y-hat. And it's some model. Go right there and I'll put it. This is the y-hat equation, which is 3.166x minus 55.797. Cool. What's it for? Well, we can model under data. This was the real life data. Maybe now I can make some predictions. Cool. Hey, I rarely see students do this. Okay? I rarely see students ever do this. But feel free to talk like a statistician. And write like a statistician. And when statisticians aren't really mathematicians. So you know how they like to write this? We got y and an x there. They like to put the words. You know what y was? Distance. So they would write this like this. Distance. And then they put the hat like this. Equals 3.166 times, what was x? Speed, okay, speed. Put a parentheses around it. Minus 55.797. Now, do you have to write it like that on a test? No. And I'll tell you, when I've graded tests for years, 99% of students like to write like this. That's how they've been trained. Plus, they find it easier to write y than this whole word distance. They find it easier to write an x, but statisticians like to have the words there, so when they plug numbers in, they're like, oh, if I plug a number in here, I'm plugging in a speed here, and it will report to me the what? The distance. So if you want to write like this, absolutely, just make sure you put a hat on that guy, right? You put a hat on that thing. But yeah, when most students, I grade tests, the answer looks like that. Cool? All right. Hey, I'm going to erase this. We're going to go to letter D. And the next thing we're going to do, I want is interpret the slope. Interpret the slope. So we're not just going to write down the slope. You and I are going to interpret it. All right? We're not just going to write it down. We're going to interpret the slope. We're going to talk about what it means in terms of this real life problem. All right? So first of all, where is the slope?
3.166.
3.166. Everyone remember this is the slope? That number, we got to talk about it. We got to put it with words. It means something. So, see this line here? When I'm going to go off this line, I'm going to draw a triangle. Really small, but then I think I'll go over here, make it bigger, and then you and I are going to put words to this. We just got to talk about this. Have you ever heard rise over run? Mm-hmm. Okay, we got to talk about this rise over run in a sentence. So over here, it's like I can make a triangle, maybe right here. You go this way, and he goes up like that. Okay, there's my triangle, but I think I'll draw it bigger. How about right here? And what I'm saying, everyone, every time I go 1 in that direction, it appears that the line went, what's the slope?
3.166.
The line rose 3.166 notches. That's what appears is happening, okay? So every time I go 1 this way, the line is going up 3.166 this way, right? Now, I need some words. What's 1 what? What is that word?
To the right.
It's, what's the variable? So we gotta get these words in here. All right.
Speed.
1 this way, 3.166 this way. We gotta talk about this somehow.
So for
All right, this one, what is it representing? The
speed.
speed. What's the units though?
Mile per hour.
So I'm thinking, okay, for every what? 1 mile per hour in the speed that I go this way,
Mm-hmm.
it looks like that golf ball was traveling What? 3.166 what?
Years.
Oh, I like it. You went back, you're like, what are units? Yards. And you and I have to just put this in a sentence. This is what we're gonna talk about in a sentence. I know we all can do that. Can everyone see that? I'll put that triangle again right here. We're gonna put this in a sentence and talk about this image. You know, 1 mile per hour this way, 3.166 yards this way in terms of this problem. Cool?
So can you write like 1 plus?
I like that. I know, that's only one thing about stats, and we do have to discuss this stuff, right? We'll use the technology to facilitate the mathematics, but we get to talk about this. All right, and before I was saying, Randy, there appears to be, you watching here, we can use words like roughly, you know, because this is an estimate. All right, interpret the slope. Here I go, and I'm gonna talk about that right there. For every, I gotta use the word increase though, would you agree? For every increase, of 1 mile per hour in speed, so I'm gonna erase this image, I got it over there. For every increase of 1 mile per hour in the club speed, or the club head speed, comma, now I gotta talk about the y variable. What's the y variable?
The distance
The distance.
increases.
And now I'm gonna put a word in front of distance if you don't mind. Oh, this thing had a hat on it, right?
So estimate.
Right, I'm like, okay, there's a y hat. The estimated distance. I'm gonna use that word. This is called y estimated or y predicted. You can use predicted distance. I'm not gonna mark off, Randy, if you just said the distance, right? Because you're talking about that line, but I should use this word estimated because it was an estimation. What's going on? All right. So for every increase of 1 mile per hour in club speed, the estimated distance will also increase. How much? Oh, I love it. And when you're not using that number,